there's a very big difference between wired communication and wireless communication. In the case of wired communication, we can have what we call digital signals. So in other words, that wire can be carrying a voltage, in this case 5 volts, and let's say that 5 volts, if I have 5 volts on the wire, it means a 1. And if I have 0 volts on the wire, it means a 0. And so I can have ones and zeros represented at different times. That works very well for digital information. However, digital information on wireless isn't quite so clear, because you can see that I don't have just a 0 and a 1 here. Let's call this 0 down here and 5 up here if we're talking about the amplitude of this wave. So this could be a sound wave or an electromagnetic wave. They all have a similar property of being a sine wave like this. And you can imagine, again, if I have 0 here and 5 up here, that I have some halfway point here, and I have some halfway point between that. If I open a calculator, let's say that between 0 and 5, right? And if I divide that by 2, well, I have a point that's 2.5 volts. But what happens if I divide that by 2? Well, I have a 1.25, and I divide that by 2, and I have a 0.625, and so on. And there is no limit. There are an infinite number of divisions that I could make. No matter how big I make this decimal here, no matter how small, I should say, that I make this decimal, I can always cut it in half. So there are an infinite number of points where here it's either up or all the way down, and it just instantly goes from one to the other. So that means that we're going to have to find some ways to convert these signals from analog to digital. And that's some of the stuff that we run into in wireless communication, which we'll be talking about in future videos.